Greeting Earthlings! If you follow the channel, you know that we love all things Apollo, and that during our last visit to Steve Jurvetson's amazing space collection, we were given the opportunity to take 2 holy boxes of Apollo electronics to our lab. These are the boxes that brought you voice, data and live TV from the moon, and should be early masterpieces of microwave electronics, the blackest of black arts in analog electronics. In episode 1, we showed how the complex S-band system worked by transmitting over 3 frequencies. In episode 2, we took a close look inside the power amplifier and learned about traveling wave tubes. In episode 3, we delve into the innards of the transponder. We think we now understand it well enough that we can attempt a power-up. And in order to do that, we must first figure out the pinout of the big round multi-pin connector. Although we have some simplified schematics, the pinout that's shown on them appears very wrong, and we sure don't want to send the 120 volts 3-phase to the wrong pins. So you have worried about the connectors.
Yeah.
And then you are busy tracing where this connector goes because there are mistakes in the schematics.
Yeah, I can show you one. I think, yeah, on this page, very quickly. It's showing pins G and H for the tracker error signal, but then also it uses pins H and J for the thermistor. And it turns out the thermistor is correct, so this is wrong, and I'm not sure what the correct pins are yet.
And it's powered by 800 hertz AC?
That's not on this page, but yeah.
Yeah, right. 120 volts.
I think so, yeah.
Is it 400 hertz or 800 hertz? Then there's some other parts that's 20 volt DC for the relays and stuff. Here is how the whole S-band system is hooked up together. We have the transponder over here that shoots in the amplifier over here that then shoots into the antenna system over here. To bring the transponder up, we'll need to hook it up according to this diagram. Let's concentrate on the transponder for a second. It needs to be powered by the 120 volts 400 hertz 3-phase AC in red here. But not only that, it does not get powered automatically when you put the AC on. You have to put the control signals in place, and that's driven by the 28 volt rails shown in pink. And these go through a whole bunch of switches that generate the appropriate signals, which will in turn control relays inside the transponder. And then there are various other points we need to hook up to once it's powered up for such things as the signal strength monitor, the various modes and low frequency inputs and outputs. And that's mainly done through our mystery round connector with lots of pins. And although this particular diagram seems error-free, it unfortunately does not have pin numbering on it. On the other hand, this diagram has all its connections on labeled pins. But we have to be super careful because there are obvious errors. For example, we talked about the same pin letter being reused for different signals, so that is obviously a mistake. Also, there are wires that go to the wrong places. On this block of 6 wires, they got 2 right and 4 wrong. So we must really be very careful when we look at those diagrams and question everything we see. This next diagram, which follows the one with errors that we have just seen, is even more interesting. That's the one which has the power supply wiring. Our transponder is shown in yellow, FM supply in the middle, and the 2 PM supplies to the right. Here are the 120 volt AC supplies shown in red. We can see that each is connected to a power supply via a group of 4 wires, 3 phases and a neutral. But when we look at our transponder, it does not match at all. The pinout would imply that one power supply is connected to 3 phases, one to 2, and one to 4, and some pins are not connected at all. There is no trace of a neutral. So that does not make any sense, this diagram must not quite correspond to the transponder revision we have. Fortunately, there are more clues. If we follow the 28 volts in pink, we see that it gets applied via switches in green to what looks like relays inside our transponder. If we zoom in on one of them, we see that each relay has a pair of coils. Aha! We suspect that these are set-reset latching relays, the same relays that are used for the disk key and that I demonstrated in that video. The set coil closes the contacts that connect the supply to the 120 volts phases. The reset coil disconnects them. So here's the plan. If we can find the 3 wires for the relay coils with an ohm meter, then we can pair the set coil. This will close the 120 volts contacts, and we should then be able to find the 120 volts phases with an ohm meter too, as they should all go to the same transformer and have the same lowish resistance to each other. And in this way we can be sure that we have the right pinout and won't send the high voltage phases to the wrong place. So we're just going to get the relays to close and making sure we know where to and try to find 120 volt wires from that.
Right, because the pinout for the connector that we have is definitely wrong.
Yeah, so we discovered that the documents have changed, or the schematics might not reflect what we have, which in this case
they're close, but they're not
guaranteed to be true. We don't want to put 120 volts the wrong place. All right, but we see the relay coils. You can tell, right? So
they're latching relays, dual coil latching relays. They have the 2 coils connected on separate pins. In the far side, the return is on a single pin, and so going across one of these pairs, I get about 1k ohm. If I go across the other pair, I get 1k
ohm.
And if I go across the set and reset, I get 2k.
2k. Okay, it's the same relay. Yeah. If we can close the relays, then we can probe the coils for the 120 volt AC on the transformer.
Yeah.
Okay, we got the fanless precision power supply, 28 volts on the dot. Ready for the click.
Alright. Ready?
Mm-hmm. That was a click. I heard a click.
Yep.
Can you unclick it? Do you want to try the un?
Let's see. So then, yeah, this should be lowercase s. Should unset it.
Ooh! Alright. We got our first sign of life here. A relay that I haven't toggled probably for 50 years.
Yep.
Excellent.
Schematics were right about these, so
it's
a good start. Alright, so let's set it again. And then we can do some probing. The schematics show pins capital A, B, C, and D all wired to this power supply, but pin A has no connection. So I'm looking just at pins B, C, and D.
Yeah, so this is 3-phase, right? So we should have...
So B to C was open circuit, now it's 53.5 ohms.
Oh, yeah, and I can check if the relay works. Can I unset you?
Yeah.
Haha! The joy of simple electronics. We have invented a relay circuit.
Yep. So that's capital B to capital C, and then B to D, also 53, and C to D, also 53.
Okay, let me see if I can unset them. Yeah, it's definitely connected to that relay. Very good. So we have found one of the power supplies, right?
Right. We're testing the FM power supply right now.
Oh, from the relay, you know, so that's good. So now we know not only that it works, but you know which one it is.
If the schematics are right, then yes.
Right. If the relays are right.
Yeah. Right. Yeah. So what I'm referencing here is this little block. It has the 3 contacts for these relays, lowercase s, r, and b, and then it shows A, B, C, and D capital as the AC power, where A, B, and C are the three phases, and D is an AC neutral. But what we think is happening is that there is no AC neutral, and the three phases are actually just on B, C, and D.
Right. In three phase, you don't really need the neutral.
Right.
All right. Well, that's good. So 2 more power supplies to go.
Yep. 2
All
p.m.
right.
power supplies.
And that powers both the transmitter and the receiver on the PM, I suppose.
Yep.
Yeah. We are getting pretty close to powering the thing up. Exciting. All right.
We are setting the PM transponder number 1 power supply.
Click.
Click. And then this should unset it.
And click. Excellent.
So let's set it again.
All right.
And then take some measurements. Okay, so this is WXYZ. Capital WXYZ. However, only Y and Z actually have connections that run to the power supply. X and W and X are no connect, as far as I can tell.
It would run on 2 phases instead of 3.
Right. So
that sounds suspicious. And is it the same for PM2?
no, PM2 has 4 wires going to it, according to the schematic. So I have an educated guess here.
Right.
The colors of the wires, there's 3 pairs of green wires, 3 pairs of orange wires, and 3 pairs of yellow wires. They come out of this connector box and run down. These are inputs to the power supply, outputs from the power supply. So there's 3 sets of 3 green wires, 3 sets of 3 yellow wires, and 3 sets of 3 orange wires that run into this thing. And they're all associated with pins that the schematics say should be AC power inputs. And I suspect that all 3 of the green ones are the same AC phase. You know, all 3 of the yellow ones are the same AC phase. So our W and X pins aren't connected. Our Y and Z are green and yellow. And then lowercase a, which is supposedly associated with the other power supply, that's orange, and it's right next to these 3 on the connector. So I'm going to guess that lowercase a is actually on power supply 1 and not 2.
Yeah. I hope that's the case, because if not, I cannot explain how this works.
Yeah.
Right. All right. So.
We got 53 ohms.
Yeah.
And then lowercase a. Yes.
Okay.
Theory confirmed.
Okay. The word makes sense. Excellent.
Yep.
So we were really worried about that, not knowing where the 120 volt AC pins would go.
Do you wanna unset this while I'm watching it?
No. Unset.
Great. So I was on lowercase a and capital Y while you did that.
Right.
Cool.
Third relay.
This should set the relay.
Uh-huh.
And
Oh, maybe it was set
yeah.
already.
So let's try to unset it. Oh,
Yeah.
it was set already.
Oh,
Okay.
so this thing was used last time. Last time it was used was on PM2.
Hang on. The other possibility is that the latch and unlatch are backwards in the schematics.
Ah.
So I have it what we think is on.
Okay. Let me make sure.
Double check.
Yeah. So.
E to F. Okay, it is open. Or I mean, it is on.
Okay.
And E to G.
All right. Found it.
And F to G.
Yes. Okay. And then if I turn it off, it's off.
Great.
So this was left on.
It sure
PM2.
was.
Cool. Don't you like hermetic relays? This, you know, 50 years after the fact, they still freaking work. Excellent. We have identified all the high voltage wires that we were worried about. And we were going to remake a control panel with the 120 volts, the 28 volts, and all the transponder control buttons when this happened. So Mike, this morning we had a little trip to Steve Jervison's garage, and we came back with some stuff.
Just a little bit of stuff.
Like stuff here and stuff there and stuff there and more stuff. And what do we think the stuff is?
This is built by Motorola, same company that built the unified S-band transponder. And as far as we can tell, this is in various pieces, this is the rack that they used to actually test the transponder.
Yeah, that's what we think it is. It matches pretty well. Transponder select, transponder mount. So this is, we think it interfaces through this connector to the connector of the transponder over here, which is different, but similar in pinout, right?
Yeah, so the pin arrangement is completely different, but as far as I can tell, pin A on this connector goes to pin A on that connector, and so on and so forth. This also has a lot more pins, which I don't fully understand. They might have just not.
Yeah, we don't completely understand it. In particular, this has us baffled. It's empty. And did you put the transponder in there and connect it?
Yeah, and then where did this connector go? Because there's nothing inside the box. These are things that we, might expect to see coming out of the box. So. Right. That's interesting.
Clear signal. So it's a breakout box of some kind. But this definitely, that would be the buttons to turn on the relays. They match 1-to-1. This we've figured out, or we think we figured out, this is internal versus external 28 volt power, and we think the 28 volt power comes over either from here or from this box, which we think is a power supply. We think this is another power supply that powers the lights. We think, and I went ahead connected it, this is 120 volts 60 hertz AC. Fingers crossed. And we think this is where the 400 hertz 115 volts comes through, which then gets routed to these knobs and these relays. Maybe. If everything's right, you plug it in. You want your safety goggles? Okay, it's in. Oh, I heard relays.
Oh, there's lights!
There we go!
Oh, look at that!
So that was correct. The second power supply, so we do external. Oh, this doesn't light up, it should have. Okay, so it has, this lamp doesn't work. FM. Okay, I'm sure all the lamps do. Oh, okay, we have some contact problems over here, or we just destroyed the light.
Oh, well, it's thinking about it.
Okay, you push things. Okay, but we powered it up. Okay, well, we can.
This light just came on.
Oh! it's waking up. It's barely alive. Okay, good. So I just spent a fortune ordering all the connectors on eBay when I could. Sometimes I could not. So we have to. Well, no, we could start wiring a few just with the pins, because I have pins that go in there. I mean, this saved us. Just spending half a day on that is less than it would have taken us to rebuild something way shoddier than this, right? Because we need to put all the AC, we need to put all the buttons.
Yep.
Hallelujah! Alright, we are making good progress, and Christmas came up early in the form of the original Kennedy Space Center test setup, which will save us tons of time admitting we can figure out how and if it works. We need to do a bit of repair to the test unit, understand how this all wires up, but transponder power up is coming up soon. See you in the next episode.